All right, guys, how about a little homework help from 3.1.1, starting with 312. This first one looks easy. Since x plus 2 and x plus 2 are exactly the same thing, I'm just going to use my laws of exponents here. And since we only have 1 on the denominator when you're dividing with the same base, in this case x plus 2, we subtract our numerators, or our exponents. So we would have 3 minus 1 is 2, so our answer is just x plus 2 squared. What that looks like if I expand it is the numerator is really x plus 2 times x plus 2 times x plus 2 all over x plus 2. So what happens is one of those cancels with the denominator, and what's left over is x plus 2 times x plus 2. All right, B, it looks like we need to factor the numerator. So x squared minus 5x plus 6. Since our a value here is just a 1, I'm basically just looking for two numbers who add up to be -5 and multiply together to be +6. And that's going to be a -2 and a -3. -2 times -3 is +6, and if you add them up, it's -5. So my numerator should be x minus 3 times x minus 2 all over. I'm just going to expand the denominator, which is x minus 2 times x minus 2. So here, obvs, those cancel, and we have x minus 3 over x minus 2. None of these are asking us to find where these functions will not exist, but obviously the numerator, x could never be, our exclusions could never be -2. That would make it 0. And you always have to do it before we've done anything. Sometimes it's the same, but before we've done anything. And here, x cannot be +2. All right, what am I going to do here? Here, I'm going to factor out a 2. I'm just looking for things to do. And that gives me x squared minus y squared on the numerator all over x plus y on the denominator. And I see now what's in the middle there, x squared minus y squared, that's the difference of squares. So I love this stuff, you guys. This is just like a puzzle. This is my favorite part of math. 2 times, okay, so what's the square root of x squared is just x, and the square root of y squared is y, and one's going to be a minus, and the other one's going to be plus, all over x plus y. All right, and here, this and this is going to cancel. So we are going to have our final answer, 2 times x minus y. And we can't have any exclusions because we don't know what would make it 0, right? All right, 313, complete the following operations with rational expressions. All right, so when we are just adding or subtracting, we need to find a common denominator. So the easiest thing to do are just multiply those denominators. So we'll have xy. So if we want them both to have a common denominator of xy, then we need to multiply this first one by y over y, and the second one by x over x, right? So now the two equations I have are y over xy minus x over xy, which is equal to y minus x over my denominator just stays xy because it's a common denominator now, and I subtract the numerators. All right, you guys, here I have 1 over x minus 1 over y times x plus y. The first thing I'm going to do, I think, is an area model. So let's do that. What does this look like? I don't know what it's going to look like. Maybe I'll rewind and redo this one if I get in the weeds, but I don't think so. We'll have 1 over x minus 1 over y times x plus y. And multiplying fractions is so much easier. So x times 1 over x is just 1, right? So if you come over here, if I have x over 1 times 1 over x, I get x over x. And even though they're both x's, anything over itself is just 1. So that's going to be 1, and this one's going to be 1. And this is going to be negative x over y, and this one's going to be positive y over x. So now what do I have? I have, if I combine everything, y over x minus x over y plus 2. And does it want me to go any farther actually by subtracting those? I could. Although I don't know if that would be any better. I could do that. If, I don't think it wants me to, but just if it wants me to, I need a common denominator. The common denominator is going to be xy, right? I just multiply those, which means I need to multiply this by y over y and this by x over x, and my 2 by both x, y over x, y. Why? Because I said so. Okay, now what do I have? I have y squared over xy minus x squared over xy plus, I'm going to have to delete some stuff over here. Two xy over xy. So I'm not sure it wanted me to get this far. But I just have a common denominator of xy because I haven't actually made it any, nicer. Although I guess, let's see, y squared minus x squared plus 2xy. Yeah, I don't know that I've made it any nicer. So I'm just going to stop instead of doing anything else. I guess I could. Well, why don't we keep going? I could factor this by saying, are there two numbers that can add up to be negative x squared and multiply together to give me 2xy cubed? You know what? I'm not going to worry about it. Let's just stop there. Let's go on to 314. All right, state all of the values from 0 to 2 pi that satisfy each of the following equations. Sketching a unit circle may help. Okay, so where is the height of my unit circle? 1/2. Where is the height of my unit circle? 1/2. And I think that is at pi over 6, right? Pi over 6 in this quadrant, pi over 6 in this quadrant, which is really 1, 2, 3, 4, 5 pi over 6. Then my reference angle 5 pi over here, which is 6, 7 pi over 6, and 8, 9, 10, and 11 pi. Oh, wait, I found something. Pi over 6. But it wants negative 1/2, so it's only going to be those where my sign is negative, where my y value is negative. So those two values there. The cosine of the square root 2 over 2 is going to be pi over 4, right, which is 45 degrees. That's where cosine and sine are both square root of 2 over 2. But we're looking for the positive one, so where is x going to be positive? It's going to be pi over 4 in the original quadrant, and it's going to be almost to the end. So 1, 2, 3, 4, 5, 6, 7 pi over 4. Okay, and then I will just have you guys do the rest of these by looking at the back of your unit circle. You should be able to figure that out because you have the whole unit circle there on that kind of like spreadsheet. All right, 315, the circle at the right has a diameter of 10 centimeters. Okay, which means from there to there, from there to there. I bet from there to there. 10 centimeters. The figure inscribed in the circle is a rectangle with the width of 2x. Express each of the following in terms of x. The perimeter of the rectangle. Okay, well, if we want to find the perimeter of the rectangle, we're going to have to find how far the other sides are. Actually, I'm going to save this for the next, because I think it's going to take longer than the minutes I have left, so I'm going to save this for the next video.